In example 1 here, we're simply looking at the sum of a geometric series. And the question asks us to find the sum of the first 10 terms of the series that begins 1, 3, 9 and 27. So what we should do here first is actually denote the formula for the sum of the first n terms, and then we can take a look at that formula to decide what bits of information we need from our given series. So the formula for the sum of the first n terms is given by Sn, which is equal to A minus AR to the n, all divided by 1 minus R. So we need a few bits of information here, and we can take a look at this formula in case we're not too sure what we do actually need. So what we need here is A. Remember, A is the first term in our series. We need R, and remember R represents the common ratio here, what our sequence is increasing or decreasing by in terms of multiplication. And then finally, we need n, the number of terms that's going to be in our sum. And the number of terms here, well, that's given to us straight away, the first 10 terms. So n is equal to 10. A, that's the first term in our series here, so that's just simply 1. And then R is the common ratio, so what do I times 1 by to get to 3? Well, that's going to be times by 3. And you can also demonstrate that here by going from 3 to 9. What do I times 3 by to get to 9? Well, that's clearly 3 as well. And that rule keeps going and going and going. So R is 3. So we've got everything we need here now. All we need to do is simply substitute into our formula here for the sum of the first n terms, where we're looking for the sum of the first 10 terms. So in that case, we write this as S subscript 10. That's going to be A, which is 1, minus AR to the n. So I'm going to do this in a bracket now just to make it clear. This is 1 times 3, that's AR. So that's 1 times 3, and this is all to the power of n, where n is 10. And we divide this by 1 minus R. So 1 minus R, where R is 3. So 1 minus 3. And all we need to do now is simply evaluate this sum. So here, 1 minus 1 times 3 to the power of 10 here. Well, that's simply going to be 1 minus 3 to the power of 10. And it's also divided by 1 minus 3. Well, 1 minus 3 is simply minus 2. 3 to the 10 now, if we work that out here, and then do 1 minus that evaluation here, that's going to give us minus 59,048. And we're still dividing by minus 2 here. Okay? And remember, because our numerator is a minus and our denominator is a minus, when we divide these, our answer here will be positive. And when you divide these, we're simply going to get 29,524. Okay? And that there is the sum of the first 10 terms of the series that begins 1, 3, 9, and 27. Example 2 here is taking a look at the sum to infinity for a geometric series. And all we simply have to do here is find the sum to infinity of the geometric series that begins 1, 1 over 2, 1 over 4, and 1 over 8. And again, what we should do here first is denote the formula for the sum to infinity, and then we can deduce what we need from that formula. And the formula for the sum to infinity is given by S, with this infinity symbol here, and this is equal to A over 1 minus R. Okay, so what we clearly need here is A and R. And again, A and R simply come from taking a look at our series. And remember, A is the first term in our series, which is simply 1, and R is given as the common ratio. So what am I timesing by here to go from 1 to a half? Well, in that case, I'm clearly timesing by a half. Okay, and you can demonstrate that by going from a half to a quarter. So from 1 to a half, we times by a half. And then same again here, to go from a half to a quarter, again, we just times by a half. And you can also demonstrate that one more time by going from a quarter to 1 over 8. So we've got A, we've got R. We've simply got everything we need now to evaluate the sum to infinity of this geometric series. Simply, all we need to do now is just substitute these values in. So A is 1, and we divide this by 1 minus R, where R is a half. So this is 1 minus a half. So in this case, our denominator evaluates as a half. So this is 1 divided by a half. And 1 divided by a half simply gives us 2. So therefore, the sum to infinity of the geometric series that begins 1, 1 over 2, 1 over 4, 1 over 8 is 2.